Hi, my name is Randy Carter with Provident. We're here at Fox Valley Technical College, and today we're going to do a quick intro and training program on the Troika Anicam analog roll inspection device. The Anicam provides several different benefits for the printer. The three main benefits that we typically see return on is incoming analog roll inspection. In other words, let's make sure that the roll you get from your manufacturer is actually what it's supposed to be and that it's a quality engraving. The second part that we see is we measure the analog rolls before they go into press to make sure that they are putting out the correct volume, that they're not dirty, they're not plugged, or they're not damaged. We typically see a big return on investment as far as color toning downtime with this particular feature. And the last one is, how effectively are your cleaning methods? Do you manually clean or do you use some type of chemical or media blasting? How effective is that? Do we need to make changes in that program so we can continually analyze and improve? So those are the three main features. To start with, we have an Anicam, we have an analog roll, and we have a laptop to run this on. So to start with, we've opened up our analog roll QC program. Now all we need to do is take the Anicam and place it up on the analog roll. A few quick pointers about handling the Anicam. You always want to handle by the main red body, and you want to make sure that the transport lock is disconnected before you take any kind of readings. So I'm going to grab the Anicam, we're going to set it up on this first engraving on our banded analog roll, and I always give it a little bit of a wiggle to make sure that all feet are actually on the roll and in contact. We don't want it rocking back and forth. And then slowly lower the head down until it's resting on the analog roll. Once it's in position, I have my Analog QC program started here. I'm going to start the video feed, and then I just need to make sure that the video feed has the correct lens chosen. So I'm going to choose the 10 power lens, and it's automatically homing the head, which is a rough adjustment. So I'm going to let it do its rough adjustment. Once this box goes away, we should be able to see the analog roll. Okay. The homing head process is complete now. All we need to do is bring the focus in. So I'm going to click my manual focus, and I'm going to give it a few clicks just until we start to see the top of the cells. This doesn't have to be precise, it just needs to be in the ballpark. But Troika has given us a focus assist module. If I click on the middle, you'll see that all the points that are in focus will turn to red. I want to make sure that I have the most red available, and then go a couple clicks above that. The reason is this device reads from the top down, so we want to position it just above the surface so that it reads and captures the absolute top of the cell walls. Once that's done, I just press 3D scan. What the unit is doing at this point is it's actually going to find its focus based off of what you told it. It's going to adjust the lighting, and once it starts, it's going to take a picture and then move down 1 micron and take another picture, and it's going to do that for 150 times. So it captures a picture every micron from the top of the cell to the bottom of the cell. This whole process takes about 60 seconds. Once all these pictures are captured by the computer, they're stored on top of each other and a three-dimensional model is made. From that, it calculates the actual physical volume of the cells that it's looking at. It also gives us a three-dimensional representation so that we can check for quality issues. So we're just about done with our 150th shot. When it does, it's going to give us our presentation. There we go. So this is what the analog roll looks like with gray. It doesn't give us a lot of information, but because this is a three-dimensional model, we can superimpose color to the different depths. We do that by right-clicking and bringing the fade all the way down. So what we've done now is the upper dark blue is the top of the cell walls, and it transitions to green, yellow, red, and pink, with red and pink being the deepest parts of the cell. It gives our eyes a little bit better communication about what's actually going on. So when we look at this, I see a bunch of red dots, a a bunch of yellow dots, but there's a couple that are missing. For instance, right here, we have a cell that's completely missing. This is a quality defect, so we need to investigate that a little bit further. What we can do is take what we call the electronic knife. I click on the electronic knife and I can basically slice through those series of cells. So I'm looking at the side profile now. And over on this, I can see that we have an entire cell that is filled with something. We don't know what it is, but we know it will not hold ink. So a good cleaning of this Anicam roll would potentially remove that. And that's something that we would want to look at. We can look at how deep the cell walls are compared to their neighbors. We can look at the shoulder angles. We can take measurements. For instance, from the top of this cell wall to the top of the neighboring one is 36 microns. We can look at the depth. So there's a lot of power inside this machine. Now, what was the actual measurements? Well, let's find out. According to this is a 700 line Anicam roll that measured a 3.0 BCM. So that is its current state. We may run this in the press, and if it gets dirty or plugged, we go back and read it, and we may see a 2.6, 2.8, or we could run this through a cleaner and we could get more volume. The advantage of the Anicam is it tells you exactly what the volume is at this time before you put it in the press. So if you know 3.0 is too little, we'll take it to the cleaner, clean it, and we should be at 3.5. A couple other things that we can look at. We have the ability to look at the three-dimensional readings to get a better view. So here's our three-dimensional rendering. We can zoom in and find that specific cell that's missing. We can rotate around and up and down. So if there is any kind of quality defect, we can begin to take a look at what it may be. You could have missing cell walls, or you could have plugged cell walls. So there's a lot of power in this. Now, if you want the more basic process control, we have the ability to enter all the information, the roll ID, the technician that took the readings, and any kind of notes that may be. Was this a new Anicam roll? Is this a new cleaner, or is there suspected damage? We can record all that data, and then we can actually issue a report, either electronically or printed, that can be attached to the roll. This can help communicate from one department to the next what the condition of this roll is. There's an added feature and an added software that will also electronically control each Anicam roll from birth till death. And that way you can see the status of the roll and help determine when it's time to take it out of service. There's a mode to take a single measurement like we just did, or if it's a full or wide roll, we can take averages. So we can read the left, the center, the right. We'll have each individual reading, and we'll have the average of all those. And on the average, it will also calculate the variance from one side to the next. One of the faults that we see the most is we'll see up to a 20% variance from one side to the other. And in Fluxo printing, if you're delivering 20% more ink on one side versus the next, you're printing unusable product. So again, if we discover this before we put it in the press, we can take measures to either replace that roll or clean the roll so that we don't waste press downtime. These are just some of the basic features that the Anicam can give to your company. If you have any questions, please contact your Provident rep and we'll be glad to arrange an on-site demo.